everyone. This is the model answer for the higher radiation exam question. The chart gives a number of protons and neutrons within a nuclei of 7 different atoms, A to G. So we've got them plotted on a graph. We've got a number of neutrons and a number of protons. Which of these atoms are isotope of the same element? The isotopes here are ones that have got the same number of protons but different number of neutrons. The only ones here with the same number of protons are B, E and G, all with 88. B, E and G. Now give a reason for your answer. Same number of protons. And you can also add on to that a different number of neutrons. Radium-226 is a radioactive isotope that decays into radon gas by emitting alpha particles. The decay can be represented by the equation below. Okay, so we've got a decay equation that we need to balance. So when I'm doing these, I like to put the numbers in for my alpha particle. Alpha particle is 2 protons and 2 neutrons. So atomic mass of 4 and proton number or atomic number 2. So that allows me to balance each side of this equation now. I've got 226 on this side and I've got 4 here. So to make this side back up to 226, I need 222. Then I can do the same on the bottom. I've got 88 here and I've got 2 on this side. So I need an extra 86. Complete the equation by correcting the number in the boxes. We've just done that one. A sample of radium-226 has a count rate of 400 counts per second. The half-life of radium-226 is 1,600 years. How long will it be before the count rate has fallen to 50 counts per second? Show clearly how you work out your answer. Okay, so when I do these, I like to start with my original counts, so 400. After 1 half-life, it's 200. After 2 half-lives, it will be 100. And after 3 half-lives, it will be 50, which is where we want to get to. So I've gone through 3 half-lives to get here. 1 half-life is 1,600 years. So if I times that by 3, I will get the time it takes for the count rate to drop to 50, which is 4,800 years. In 1927, a group of women who had been employed to paint watch faces with luminous paint sued their former employer over the illness caused by the paint. The women had been told that the paint, which contained radium, was harmless. The company owners and the scientists working for the company knew that radium was harmful and took precautions to protect themselves from the radiation. The women were given no protection. What important issue did the treatment of the women by the company owners and scientists raise? Draw a ring around your answer. Okay, so this is ethical. Okay, so the women, they were lied to, they were deceived, they were not warned of the dangers. So lied to and not warned. Okay, so the people that they work for, they value their own lives more than these women's lives. They will protect themselves, but they won't protect their employees. Very ethical argument. In the 1920s, many people, including doctors, thought that radium could be used as a treatment for a wide range of illnesses. Medical records that suggested radium could be harmful were generally ignored. When some of the women who had used the luminous paint died, their deaths were not blamed on radium. Suggests a reason why the evidence suggesting that radium was harmful was generally ignored. Okay, so for this one, there's a couple of things. Lots of people wanted to use radium. Alright, so they're wanting to use it in these paints and in other things. If it was dangerous, they wouldn't be able to use it anymore. Okay, so they might lose money, they won't be able to produce their goods anymore. They also don't want to be blamed for the deaths of the women or the illnesses. So doctors didn't want to be blamed for the deaths or illnesses caused by this. For illnesses caused by radium.